Hey, Coffee Compiler Club. Going to talk today about anything to do with compilers and language runtimes and typing systems and function syntax and whether or not you should use arenas when you're arena allocations when you're writing your compiler. It was all over Discord this morning. Um, we're all being recorded live. Show up on YouTube in a couple hours, sometimes a couple days. So I have a initial thing I want to start with, which is not a huge deal. And I am looking for the correct window. How about this window to share? That looks better. So I'm looking, I want to do something with function syntax for simple. What am I doing with functions on simple? So it's not yet, but because I'm doing other things this week, but at some point I'll be doing function syntax. So my current theory is I'm going to say I have a function type which uses the open curly as the hint
Could you
that it's
zoom
a
in a
function
little
type.
bit?
That's the easy syntax.
Yeah,
A little. Can you zoom?
like
Oh,
150 maybe.
Yes.
yes, I can zoom.
Mm.
Google Docs or
Oh, you have this 110% in your address bar.
Yeah, I was thinking I would use the docs, which has a zoom in
Or
it.
that, yeah.
Used to. I cannot find it now.
Interesting.
Um, that's probably not it. How about this?
It,
How about
Mhm.
now?
Yeah.
yeah, it's better. Thanks.
Yeah, if the docs do it, it will get. Oh, there it is. I found it. Hang on. They'll do a font thing instead of just a blow ups right here,
Mm.
or they won't. I'm just hoping they would.
No, that may be actually good because I think the address bar is not taking up space now.
Okay.
Yeah, that works. Thanks.
Okay. So function types start with open curly. Um, Let me grab, and then there, the actual normal function type statement would be some type variable is equal to function type expression. And so the function expressions themselves, here, let me do var in a second here. So here's an example
Mm.
where that's a function expression. So functions are expressions. Function types are, oh, I'm sorry, the functions are first class citizens. These are not closures, they're functions. But you can assign them to variables. They can be anonymous, just like I wrote there. Um, you can, and then I have and because I don't want to write the darn function expression here. This is a good example. But here's another version where I'm showing the type. Oh, Google, what are you doing? How about now? So there's a type, a variable named distance, an expression, which is a function type expression, which computes the square root of x squared and y squared. That looked clunky to me, so I came up with var for this chapter as well, which is pretty straightforward because I can infer. Oh, you didn't cut and paste. Look at that. I'm switching between Emacs and Google Docs, and they're disagreeing. And a couple things here. So var would be used anytime. I can always use a var in front of a variable declaration because I always do forward flow typing on the right expression, even during parse time, would be take that, make it the glib, and then declare that's the type of the variable, the greatest lower bound. And that means I can use that in any context except on function headers. So you could always give a type and you could always say var, except for function headers, which have to name the variables. That's not helpful there. And then after the arrow, you have a full block syntax, any number of statements in a row, and I'll take the last statement as a return, and I would drop the return. Drop the return keyword from simple and just say The last expression is the value. Done.
Hmm. Yeah, that will be probably fine. Because there are a few cases that you want to return not the last thing in the block, but
Well, if you want to have a return in the middle of a block, you're going to have to say return. That's
yeah.
one way to do that. There is another way, which is simply say that you don't get to return out of the middle. You have to go to the end and with
Mhm.
if then else's. But I think returning out of the middle is fine. And the return at the end could be optional. I don't have any trouble taking a return at the end, just making it an optional thing. That return keyword could just be optional.
Yes, it should probably. The last expression should be the return, but we
Okay.
should support the return also in the middle of the block.
Right, right, right. So that's like I have another case here. Yeah, here. Here is another case, which I'm going to fiddle with. The spacing's all broken because Google. Okay, hang on. Oh, wow. What are you doing, Google? Well, I don't know who done the spacing game here. Somebody is confused. Oh, I see. This should be 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That looks better. Okay, so how's that? Newton's approximation to square root. I use var guess is, x squared over 2. While 1, var next is x over guess plus guess over 2. That's fine. And then there's a return in the middle. There you go.
Hmm.
And that looks to me like that looks like a reasonable function syntax. But I'm willing to be talked into something else.
Hmm. Okay, so that that looks that looks reasonable.
The because the functions are anonymous, you can drop them in anywhere.
Hmm. Hmm.
And if you want to name it, you put it on a variable, and I can probably come up with a name for it, but it's not necessarily has anything, it's just another variable name. So somewhere down below, you could say, give me a square root of 2,
Hmm.
right?
Yeah.
And you just call it like a function. Oh, somebody has something in chat. Why do I need the outer curlies? Oh, wait, no, this is yes.
The only thing that I've seen a bit similar but actually different is the OS programming language. It's this multi-paradigm programming language from the 1990s. And this one uses curlies slightly differently, but interestingly, to basically surround the identifiers and function calls. If you look at this factorial example, I think you have
Um,
scrolled too far.
Found
Yeah, way too
division,
far. Just
or
go
too
to the
far.
first functions example.
Anonymous
Just
functions.
click on functions on the left.
Oh, I see.
Yeah, that's the easiest one to read. So you see, you can introduce function factorial by surrounding with this curly braces, both the identifier fact and the argument, and then you follow the same in the call syntax in the else branch when you call it. You also have the identifier and the argument. So that actually I found that weird when I learning OS, but just throwing
I,
it out there that there is one other language using curly braces just a little bit differently.
I like using normal round braces for function calls. So var fact is equal to int x arrow, and then it's if x is less than or equal to 1, return
I don't
1,
recall the
else.
motivation for that, but I wonder if that was an attempt to have a function call syntax that follows the function declaration syntax and yet is not as crazy as C. Because C is the only other language I can think of that has this exact declaration follows use syntax, but I think C syntax is crazy. You have to learn the spiral rule and it gets really
I'm sorry,
complicated with function pointers.
back up a second. I have I missed, you said something about C as the other language has this declaration
So
follows.
the principle that both OS and C are doing, but doing very differently, is that the declaration syntax follows the use syntax. So if you notice, you've called the function in os exactly the same way as you declare it.
Oh, I see.
Literally exactly. You always write curly brace,
Right.
identifier, and then either argument or parameter, depending whether you are calling or declaring. So
Oh,
the only other
interesting.
language that follows that rules is like in C, where you have also declaration follows the use syntax, particularly for pointers. But I wouldn't follow that principle in the C style today because I don't think it's very good with the spiral rule and the operator precedence ambiguity.
Yeah, I'm not. I like rounds for doing function calls because it matches the C-like, Java-like syntax, so it's the least principle of least surprise.
Yeah, but you are changing the declaration syntax
I
now.
am changing it, so I'm limiting the amount of changes here. And Manas, I'm using the outer curlies because I need the curly to denote the start of a function expression.
Out of curiosity, why not C style or Java style syntax also for function declarations? I guess there is a reason, right?
Well, I want to have an anonymous function. So start with the anonymous function syntax. Given
Hmm.
you have an anonymous function syntax, assign it to a variable. It's just an expression that produces an anonymous function. Now take that anonymous function, use it in your other larger expressions. And then at that point, you don't need anything other than the normal variable syntax.
At the risk of posting something really cursed, I have posted a block example. I'm not sure you have seen that.
Where? Well, oh, just in chat. Let me go.
And look at the abstract declarator. It's almost at the very beginning. You're gonna see the abstract declarator. Yes, here. So for example, here you have the abstract declarator of a function from char and float to an int. This is kind of cursed, but it basically allows you to have anonymous functions in C, Objective-C.
Oh my God.
If you
I
can,
like my syntax better.
but yours is similar because now if you scroll down to this hello world example, it's going to be in the under the block literal expressions. Already you can see the section at the bottom, and now scroll to the end of that section. Yeah, you have this hello world example. So
Uh-huh.
this is kind of how you can declare a block with no arguments and no value. So from
Right.
void to void, that calls the printf inside. There's
Yeah.
a little bit similarity to what you're doing. Just
Right.
use a caret. Instead, you are using curlies.
So I can take a short. It's no. There's no ambiguity for taking the shortcut, or if you have no arguments, to drop the arrow. So that would be a no arg function would just say, oops, let's see here, done. So
Aha,
because
so whenever it's a curly braces delimited
right, so as soon as I have
sequence.
curly braces, I know I'm on a function. Now, if I don't see an arrow, I have no arguments.
So that's kind of your carrot then, in a sense. Well,
Yeah,
carrot
right.
followed by curlies actually are just curlies.
Just pointing
Interesting.
out I can just drop the curlies if I got no arguments. You drop the arrow as well. Not drop the curlies. Drop the
You
arrow if you
can do
got no
something
arguments.
similar. So in the block syntax, you can just write carrot instead of the arrow, and then you outside of the braces, and then you have the exact same thing. It's also in the
Yeah.
example.
I mean, I
Drop,
think
It's
the
dropping
concept
the
here is I
arrow.
could wrap curlies around any chunk of code
something, yeah, like
and
that.
declare it a thunk immediately.
Hmm. But
Except I don't do closures, so you don't do environment capture.
hmm.
Are
More
you
of
planning
this
to do
big.
closures,
So
or are you?
so the line down below is a valid one for me. There's a no arg function. So if you want to have another syntax, put it on a different line.
Are you planning to do closures at some point, or at least not preventing yourself by reserving some kind of syntax for capture lists?
Oh, I see. Yeah, so right. My current theory is that I was going to not bother with closures in a tutorial because there have a lot of subtleties.
That makes them one of the most interesting things to cover in a tutorial.
Well, but the tutorial's goal was to not cover syntax and semantics as much as how you take it from semantics out to machine code. So
So
if I can
basically,
leave
that
a,
I know that C of nodes is like the core idea, but I actually wonder if there is something interesting to cover in the C of nodes port closures in particular, or
Hmm.
would that be not necessarily
so
anything
so
new?
we could go there. It's not that there's no, as far as I can tell, there's no real synergy. So if I allow functions to capture outer scope, um, then you end up with the thing where you have to have somebody has to come along and count who's in the outer scope and declare the lifetime management. And the standard sort of behavior I'm doing here with function calls and the like turns into a series of unrelated functions that get compiled as a parallel set of functions that then intercall with each other, plus or minus n9. Yeah.
So you'd be doing some kind of lambda lifting anyway, right? Where you'd be promoting list of functions taking additional
Yeah,
hidden
so then
arguments. Okay.
immediately I'd have to go to lambda lifting or closure conversion.
Mm-hmm.
And I don't know that that needs a syntax change in the language. I would just say it used to be illegal to refer to things out of scope. Now it's legal.
Right, except if you do want to have some control, whether I capture this one by copy, this by reference.
I would claim that I would give you a single flavor of capture, and if you want a different flavor, it's your job to make a copy. So this like
Mhm.
gets into let's make a different example where we discuss what capture is sensible or not, um, and what it means here. So you know, the obvious one here is to say var x equals one, and then I make a function here. Var function is it takes a whatever and a y and it does returns x plus y and maybe, and because I'm trying to be evil here, it's going to do this, right?
Yeah.
Okay, so it's side affecting the outer guy. And
So I would
then,
say that I would be very tempted for the default for something like this to be captured by not only value, but immutable value. First of all, value because it's an integer and it's just silly to pass even 64-bit integers as 64-bit pointers, let alone if you had something like 32-bit float. I would think it's a very bad idea to pass 32-bit or 16-bit float by as a 64-bit pointer. That's one thing, and the immutability, I think it's just got a default nowadays. I think that's one of the mistakes in C++, not for lambdas, actually, they did fix it for lambdas, but in general, even for scalar values, to allow mutation by default. I think you have to say something specific like mutable or mute or bank to say
well,
that
so,
I'm gonna be changing this X and this is going to leak out to the outer scope. I think you have to be more
okay,
specific.
so the current simple syntax is mutable by default. If I put a bang on it, it'll be immutable. This code would then declare you can't mutate X.
Oh,
Fine.
I would flip that then.
I'm sorry, you would what?
I would flip that. So I would say that
Yeah.
bank is something special. That's something weird and strange, exotic, so mutable. And the default is when you don't write anything. But
Um,
again, I think that C++ here make a mistake.
Yeah,
That's
I mean
basically
the
the
kind of
goes
the
default
goal
language.
there was the simple language. So that's different from capturing here. That's just about mutable or not for the default. That was the simple language being as close as possible, as sort of reasonable to C/Java in order to not mess with people who are just there to learn how to write a
Right.
compiler.
I think it really I see the point, but I think it depends on where you're coming from, because many people today may not be coming from C or Java, but for example, from Rust, and they probably would expect immutability by default, or Swift, or TypeScript. Like
Okay.
all of those more modern languages, I think today start with
Mutable by,
immutability.
yeah, okay. If I do a
Even
I
for loop with an iterator, I want it to be mutable by default, but that's a different thing
Yeah,
altogether.
but me and you don't count because we have started from at least C or assembly, so too
So
late
let's
for it.
claim this is immutable. However, I do that. I don't like
Yeah.
this syntax. But in this guy here, back to the closures, you think it's it should be an immutable capture so that when you later call function here, that is to say, down here I say function, and I pass a 2 in, and I go print this, and it prints 2 for y, and x was a 1, so it's 1 plus 2, so it prints a 3, and x is set to 2.
hmm,
And then I would print x, and then I see, x equals 2. That's the capture escaped, right?
Mm.
And now, is this more or less what you might expect? Like, I can totally make examples that go both ways here. There's including
Mm.
things like, I have a count of things I'm looking for, and I have a complicated search expression over a large data structure. And in the body of one of the searches is I found one, and I bumped the global count. I'm totally bumping a global count or external function count all the time in some nested find operator. So here I have, a mutable count starting at 0, and then I have a for loop over some element E out of some huge collection. It does something. And then from here, I've said, E dot predicate. Oh, I have a predicate function that takes me an E, and I want to say if predicate count plus plus, except I had to nest this inside several layers of things. So I passed in a function, an anonymous, whatever, some other. Maybe I don't even have an if here yet. Let's do this. Here I'm making my E as my filter. And say, if filter more is the function, count plus plus. So I have some horrible collection and I run it through some other function and I hand in this thing, which is going to take some element E, which has been further mangled by some other, and then it bumps that count if it found it. And you get these kind of test cases that look pretty reasonable when you want to have the outer mutable. And then the other one of those is to say it's just not. And then this, then the Rust syntax says, I come back up here and I say, well, you are a var and that defaults to immutable. And then it's error X is immutable. And that's how I prevented you from mutating it weirdly. But if I wanted to pass a private copy of X that you are going to mutate yourself, but be independent of the other one, I claim you just make a separate argument on the function.
You know what? I would say that actually I'm not quite sure I would know the answer that works for most people in general, but I know one good person to contact or who would know is Professor Sriram Krishnamurti from Brown University. He's been doing this research basically on how learnable and teachable are programming languages. And he was doing things like comparing, are these reference semantics expected in this expression or not? I think there is a comma
Your
that
link
should
didn't
be there
work.
at the end.
Uh-oh.
I blame Zoom. Yeah,
There you
he's
go.
basically been doing that. Those things, are these behaviors of the language expected or not? If the students look at this language, are they gonna screw things up? Because we as professionals, we know how languages should behave because we have used them for decades, right? But
Right.
if you throw someone who hasn't, then they can have very different things that are difficult for them and things that are surprisingly easy for them. So that I think that kind of stuff may be interesting to look at.
Mm.
That and this other thing, I think I posted the other example,
Oh,
but he
I'd
has
have to
like a
read
ton of
this.
research in this area.
Right. I'd have to read this like deeply for a long time.
Yeah, yeah.
Yeah. Mostly I was avoiding closures because I didn't have to answer these questions.
So also
Mm.
profiling programming language learning, which is
I'm,
basically
I'm,
like you can profile program
Right.
for performance, but you can also profile programming language for how easy it is. So I think it's interesting to look at.
These are all like pretty much spot on what I'm
Yeah,
doing.
he's pretty much calling it this like the standard model of languages. Like you have the standard model in physics. I think that's the inspired
Right.
name.
Right. Right. And then this, except for this one, would say close over lexical bindings, which I'm dodging right now. Because this got closed over from here, and then I have to do lambda conversion or closure conversion or lambda lifting or something to rescue it, which,
mm.
can be done.
So I would say, without closures, the language would feel incomplete.
Without
So,
closures, the language
mm,
feels incomplete. Holy crap, no one's had closures in a language or
mm,
mainstream top level languages haven't had closures for, I want to say, They showed up a decade ago in
Yeah.
sort of mainstream things, but like Java's not got closures. C doesn't have closures. You know, I don't know. Does Swift actually have real true closures? How about Python? I don't think Python has closures.
Hmm.
I'm not saying we no to closures. I'm just saying this is definitely a step up in scope for this project.
Yeah.
My next, most called for thing is code generation, sort of obviously, since this is all about a compiler going down to code gen.
Are you
So I'm going to
gonna
Yeah,
throw down functions and then do
are you
code.
gonna do both? Would it be interesting if you do more than just one ISA? So not just x86 or just ARM64, but both, because it's interesting to see how you abstract over the common
Yeah.
parts so you don't have to repeat the
Well,
work.
RISC-V. I need a VM that runs either ARM or
Uh, if you
RISC-V.
want to do AR64, install QEMU user, then you can just run those things from your back command line from bash. So you can literally just stay in your ordinary command line and just run the executable. QEMU user, highly recommended.
Wait, what was this?
It's QEMU user space emulator, but if you remember, if you install it in for Linux, it's gonna be possibly in a different package. But Google QEMU user.
About to say, can
QEMU.
you throw the
Because
link
it's
in?
not a full VM, it's just user space program. It's called QEMU, Q, and
Yeah.
then emulator, one
QEMU.
word. Exactly, QEMU, just one
Oh,
single M.
QEMU.
Yeah,
Oh, I've heard
user,
this thing.
user.
Oh, user.
But that's the part of the same package. Yeah, you have it in
it's
the
pretty standard.
you see in the you have those three modes of emulation: full system emulation when you want to emulate entire operating system, user mode emulation. This is what I would recommend. This is just running programs, just in ordinary executable. You can even see this screenshot,
Huh.
but he's using this on the x64 Linux, but he's running this QEMU ARM LS, and this LS is actually an ARM executable, so he's able to run ARM executables on x86 machine, which is probably what you want.
Which is probably what I want.
I think that's the easiest, the fastest, and
Okay.
the least lower hanging fruit. I would definitely
That's
go with QEMU.
interesting. All right. Hey, I've
I
seen this
have
for years, but I've never actually used
I
it.
actually use this for compiler testing exactly in this scenario. When I have x86 machine and I want to test for
Right.
some exotic ARM target, that's the way to go.
Right. Well, what would be the second target? So x86 is the first target.
Risk
The second, is it
5.
ARM or
I would go with AR64 to be honest, because it's the most interesting. I see in Risk 5 right after, but I
you
yeah,
would
said
say
ARM5.
x86
AR64?
and
Is that ARM?
AR64.
Is
ARM
that ARM?
64, I think it's also very interesting.
No, no. I'm asking AR64 is ARM.
Yeah,
64-bit ARM.
yeah.
Is it
Yeah,
it's significantly different than 32-bit? I don't know.
I ignore Risk 32-bit unless you want to do embedded.
Fine.
I
Okay.
vaguely remember differences between there was like some kind of there's something
32-bit
that
has
was implicit with like before the 64-bit and then they
it's
removed
it's
it.
different. Register names have changed from R to X, and 32-bit a while ago also had this compressed instruction set
Thanks for that.
subset called TAM2 when you could switch from one ISA to another mid executable. I don't think you want to mess with that.
No, no. And I'm not going
No.
to do like all the
64-bit.
horribly fancy x86 ops here.
And notice that because you may be running under QEMU, you can play with SVE because QEMU definitely emulates SVE instructions on x86. So you can actually target vectorization using scalable vector extensions if you do that.
Um, yeah, I wasn't going to do vector ops, at least not in the first cut. Because like to do vector ops, really I have to start with doing real loop operations. So I would say, after functions it was going to be cogen, which
Yeah,
would be your question there. But then to get to vector SIMD ops, it's going to
I think that's
be
can wait too. I
range
agree.
checks on arrays plus syntactic sugar to make
It's just
making
that
arrays
if
easy.
someday, I agree, this is something that can wait. It's just if someday you
Okay.
do, then I think SVE is a bit nicer than Neon because it has scatter and gather, so you can emit more regular code without messing around with early exits and stuff like that. So I think you will
Oh,
find SVE cleaner, basically. Less hassle to
I
do.
see. Fine. This is one of these funny deals where when I got done with doing SIMD at Azul and at Sun, there was no issue about early exits and the like. That was all taken care of. I only handed the SIMDizer loops that were unit strides of the length of the SIMD ops directly.
Right.
And and then I just said if there were edge cases, I wasn't trying to do super optimal when you had short loops and trying to run SIMDs.
Yeah, and to be fair, it will not be super optimal either. I mean, because I mean, predication is just one choice. I mean, the textbook example, if you have, a loop that is not equally divisible by the vector size,
Right.
so maybe you don't have 1024 element loop, but you
Yeah.
have a 1000 element loop. And then
Right.
you took one classic solution, of course, is to do the remainder loop. Is
Yeah.
basically split the loop into the equally divisible and not.
That's what I was doing.
And the other is predication with
Right.
SVE, you can just keep it in one loop and you're gonna predicate the operations on the active elements in the vector, for example.
Right. I was
But
not
it's not
thinking of
necessarily
doing
gonna
that.
be always faster, to be honest. So it's simplicity of code gen is more of
Uh-huh.
an
I was
idea
trying to
here.
get the job done without spending my entire life.
Exactly.
This is yeah. Okay, there's a QEMU looks really good. That's a thing that I had heard about and just not really realized.
Yeah,
I
the
know it
user
used it.
mode
So.
emulation, I think it's really the way to go. The only thing is it is running under Linux. I don't think it's available for anything else, like
Somebody looks like
Windows.
they're trying to fake a Windows
Yeah, but
emulation
if you are
in it.
gonna be doing this under WSL, then it should work.
Oh, I see. Yeah,
I'm
okay.
not sure how well it worked there, but I was wondering, does QuickEmu let you debug easily?
Oh
You
God, I
can
have no
run this
idea.
with GDB if that's what you're asking. And there is basically you can set it up as your remote target. That is similar to if you worked with embedded, you probably use GDB setting your embedded board as a remote target. You can actually do something very much the same with QEMU.
So if I wanted to test ARM neon instructions, it's going to be like dead simple to like see the
Yeah,
hexadecimal.
just run this under QEMU user. That's the way to go. Just
Yeah. Okay.
print one binary to the command line and that's it. The only difficult thing is if you had something fancier like runtime library dependencies, like if you're doing full C++ compiler, then of course you have to make sure that what you are going to be dynamically linking with is going to be in the path of that user mode emulation. But you can definitely totally make this work. I have made this work. I am actually doing this for C++ applications with dynamic linking. So
Uh,
it's all doable.
Hmm.
There are some good blog posts, but I think you can just Google things and just look for the newer
This is one of these deals where
solutions
I'm
and
I'm
it should be
kind
fine.
of looking at it like debug info in an output binary format. Looks like I don't want to deal. I'll figure it out.
So no
Yeah, the
closures?
jitting thing does no output format issues. You just throw bits in a buffer and then you execute the buffer. Done. But if I have to go to like dwarf or elf or pick your output format of choice.
What's kind of also cool about QEMU is that it's kind of smart, is that it doesn't emulate unnecessarily. So for example, if you have physical box that is ARM64 but without SVE, and you're gonna emulate a binary with SVE, it's actually only gonna be only emulating the SVE instructions and just hand off the ARM instructions to ARM CPU without changes, so it runs at full speed, which is actually pretty darn cool, I have to say.
Okay. Yeah. Well, I don't have an ARM on my desk, but I have an
Yeah,
x86.
like if you have like cloud instance, of course, cloud instances nowadays have SVE anyway, but there was a time when they didn't, and that's
It was
pretty
the way to
cool.
do it. Yeah. Okay. Yeah, I kind of had in my head I was going to get as far as I could pull up CodeGen on Godbolt website and then compare versus Clang and the like, and then stop because the simple wasn't the language I wanted to write. Simple was the demo I wanted to write. Figure it out
uh,
after that,
I
and then stop at some point.
I was kind of wondering something about simple. Um, so there's the compute and idealize. Uh, is idealize only called within peoples and other idealized functions? And how do you decide what should be in idealize versus compute?
Yeah, there's a whole long story there. The short
I just want
answer,
the short version
yeah, well,
because
the long story has some interesting stuff in it. The short answer is idealized is called from inside the people opt in no other place. So no people calls idealize, peoples call peep, the people optimizer, which calls idealize. But the people optimizer calls idealize in this framework that lets him then make adjustments to the graph. There's the graph rewriting, graph editing as the result that came out of the idealize call. The value call has a different story. So idealize is all about rewriting the graph. And a value is about computing the best available knowledge about a single node. So if that knowledge turns into like it's a constant, then you use it to rewrite the graph with the constant replacing some computation expression with a constant. And the other piece of value is that it can be used both top down and bottom up. Bottom up means you can use it while parsing. So if I read some expression in the parser and I put some nodes out and it computes something and I read some other expression and there's an add between these two and this whole expression computed something like a constant 2 or a range or whatever, and this one computed something, and then I added them, the compute call adds them at that time during parsing and come up with a correct valid answer immediately that's, as good as you can get without knowing what the rest of the parsed program that you haven't yet parsed will do. And if it turns into a constant, you can immediately replace it while you're parsing, which is what simple does. And that might constant fold, dead if tests and the like. The top-down version is the one that says, start everybody at their most optimistic values. And where there's a direct conflict, like that's not right, you compute a value call and it's some other thing that's going to be lower in the type lattice than what you started with, then you lower it. But that means that other people's inputs are lower, and so they probably compute, they compute a new value that's lower. And you repeat this process in a work list until it stabilizes. And the mathematical proof says it's at least as good as the bottom-up version, and it could be better. And in practice, it's usually a little bit better. It finds more dead constants and more dead loop tests and things like that than the strictly bottom-up version. And that would be called conditional constant propagation, and on CF nodes, it's sparse conditional constant propagation. There's an official, academic name for it, SCCP. So the compute call is used both bottom up and top down. Top down, it's the same as SCCP. Bottom up, it's just constant folding. But value is just used to say something about a node.
I think I might have not noticed that you sometimes you call idealize when the function is not completely parsed.
It happens whenever you call people, and that happens while parsing in statement by statement, instruction token by token out of the parser. So you go idealize basically after parsing every token in the parser.
Okay, yeah,
I can demo that live.
No. I read that in the earlier chapters, and then I skipped over to the source code of the like 14, I think.
Yeah, you missed.
And I just like it just threw me in a loop because in my own compiler, before I even looked at simple, I actually had a couple of things that's in idealize in my compute function. So it was just like different because I just like squashed them together, and I wasn't really sure why they should be separated.
So this gets into the longer story.
Yeah.
So
no. You answered it. I was just like, it was just like weird to me on my first the first look through. So because I haven't like stepped through the code entirely. So even though I wrote it, I'm not 100% sure what words called in and all that.
So the thing to think about with the compute call, it's a value in AA and C2 and compute because Debian wanted compute, fine. The thing to think about the compute call is it's a purely a functional call. It has no side effects. It reads neighbors, computes a new type for the current node, and hands it back to somebody else. Which means you can step over a compute call and look at its result and decide you don't like it, you're confused, and go in the debugger and pop frame and re-execute the compute call and single step it and walk it through. So compute calls are always free to call. They have no side effects. They just return a value. For debugging purposes, it's very convenient that you have a set of these things that do something fancy and complicated and produce good answers that you're going to use to optimize, but they have no side effects.
I
So
see.
you're always free to call them in debugger. They can show up in 2-string calls in the debugger. You stop somewhere and immediately the value call and the cached value are both available to you. And you can just eyeball them. Oh, look, he can make progress because his value call changes. But the act of calling the value call didn't actually change anything. So that's convenient. Idealize calls change things. They have side effects. You can't recall them. So if you're trying to debug a broken idealize call, if you catch it after it's done, it's too late. The graph got trashed. What was it before it got trashed? And that leads into how I debug them with this peephole counters and binary search on people. No, actually, binary search on people is very often. It happens, but it's really rare. Way more often, I catch it soon afterwards, and then I start breakpointing around, and then I catch it just immediately after it's broken, and I get a count number, and then I just run the loop, hit the count of whichever peephole number, and then I single step the idealized call and say, oh, wait, I forgot this check, and it did this thing, and that's why it's broken. But yeah, idealized calls have side effects, so you debug them differently. The longer story, which is not at this point, there's not much longer left to it. In my
Okay.
thesis, I combined global value numbering with global the compute call and some not idealize in general, but things that computed identity functions. Because identity function computation is very similar to global value numbering. These two nodes compute the same value. And value numbering does it by doing a hash on the inputs and opcode. Same inputs plus same opcode must compute same value. So you just put them in a hash table, done. But you also have things that compute identities like add plus 0, subtract from 0, multiply by 1, and then I had like 10 more. Loads and store ops that feed from each other account. You know, if I store a value and immediately load it, that's an identity. Those turn into identities around fee functions, around loops, which means you can't discover them in any bottom-up idealized call situation, but you can in a top-down one where you're doing global analysis of things that are equivalent. It's a different algorithm. And so in C2, I broke out the identities from idealize. So in simple, idealize covers anybody who hacks the graph, including things that say, oh, I'm an identity on this other guy. And then as part of that, the idealize call just hands me a replacement. It happens to be some other prior node in the graph. And you know, the editor swaps it. Well, the same thing happens for an identity. It's just some prior node in the graph and you swap it. But if the identity is now a pure function, I can use it in this optimistic way. So it has no side effects. It's an identity call, unlike idealize, which may have side effects. The identity version has no side effects. It just returns the replacement. And the idealize calls, which just return the identity, just return some replacement, they have no side effect. They just did a test. Hey, it's an add, and the right-hand side's a 0. I return the left-hand side. That's no side effects. I just told you, here, I'm identity on this guy. And then the people has on, you know, the graph hack, and he made a side effect, hacks the graph. But now that I have this concept of I have an identity, then I can go to the global optimistic top-down version and say, if this were to be an identity and this were to be an identity to that, then these two things would be an identity, and this if test would compare true, and then this code would be dead, and if, and then, oh, it's all true at the same time? I have an answer, and you can get that in a optimistic solution that can't be solved any other way. So there is a concept that says I should break out the identity flavors from this general idealized rewrites because there is an optimistic version of that algorithm. Gets better answers, strictly speaking. And that would be, in my head, a useful thing on simple as well. That would be a public domain available version of my PhD thesis. So I'd be motivated for that one. As opposed to trying to sort out what you want in the most convenient, easy to use closure conversion world. Although I'll read your website there, Matt. I'm very curious to see what he says about what people believe is a good answer on side effects with captured variables. I haven't decided that. I know that the ecstasy guys, like Cameron and Gene, they did a crazy thing. They allowed all possible things, and they all knew that it was all broken different ways. And I might, in order to support whatever they're doing, end up having to do horrible closure conversion things already. But I'd rather see somebody who did some research and said, "Hey, we tried a bunch, and everyone's confused here," and I could agree with that. All right, closure conversion, identity calls, idealize calls. What else? Small group today. If everyone's gonna be quiet, we'll be done early. What we got here? Vesher, Brown, Windows. QEMU was a good one. All right. Well, we could go tell people to, recover from Halloween and be done. I don't need to have doesn't have to be 2 hours long. All right, I'm gonna do it. We're short today, and that's just what it is. That's okay. Better high quality than dragging it out.
Yeah.
All right, folks. Thanks for showing up.
See ya.
Bye.
Bye.
Good weekend.